All right, AP Calculus AB, Unit 5, Day 8. Assignment. These are the answers to the multiple choice questions at the top there, which I think I posted online also. So this is a really big assignment. There are some, let's see. Anyways, so check those answers if you haven't yet. Gotta show work. Okay, here we go. All right, you guys should work on these. And sometimes more work than you would if they weren't multiple choice, but at least multiple choice questions, they give you the answers. And sometimes looking at the answers before you even start might give you some good ideas of how to approach the problem. But just taking derivative of this 4 2x squared plus 1 to the third power times derivative of what's inside. Don't forget the chain rule. Now, if you looked at all these answers, I think you might say, oh, I should do chain rule. I mean, we could have expanded this binomial with Pascal's triangle, whatever, and did the derivative that way, but then that's not even a choice here. So that would have been, even though you would have gotten the right answer, wouldn't have been a good. Now, there's some answers on here, like this person forgot the chain rule. This person did the chain rule, but maybe forgot to do the 4 in front. There's a variety of different things, but this is going to be 16x 2x squared plus 1 cubed. So it's interesting to look at the wrong answers because that's the one tricky thing about multiple choice is even though the right answer is there, the wrong answers are usually really close. They're really based off of usually very common minor mistakes. They're not just like totally horribly wrong answers. This one, we do the derivative at 0. So let's do the derivative first. I would like to think of it as a exponent. Everything inside stays the same. Subtract 1 times derivative of what's inside, 4 cosine x. And then we're going to plug 0 into it, so we don't really need to make it pretty or anything. 4 cosine 0 over 2 square root 4 sine 0 plus 2. That's a 1. That's a 0. It's going to be 4 over 2 root 2, which is 2 over root 2, which might be on there. I mean, that's possible. It doesn't have to be rationalized, but it's not. So got to probably multiply top and bottom by root 2, which gives you just root 2 for your final answer. The other thing about multiple choice is it's right or wrong. No partial credit, unfortunately, on tests. So it's kind of harsh. Make one little mistake, no credit. Okay, this one right here, I think it would be good to think of this as x to the first and x to the 1/3, and rules of exponents be x to the 4/3. So then the derivative is going to be 4/3 x to the 1/3, or 4/3 cube root of x. There it is. So that one I think was all about just rewriting the original function into something more friendly. Otherwise, if you're going to do like product rule with this, that would be horrible. I mean, you should get the right answer, but it's going to be way harder. Number 4, again, look at all these answers. And when we get our answers, they might not look exactly like this, but we'll try and make them look like this. Now, I think we would have to do a product rule here, right? Mainly, it's the big picture rule is product. So it's going to be x times derivative. Now, I haven't taught you the derivative natural log of x. I'll just tell you what it is right now, and we'll talk about more next chapter. This is probably one of the only times you'll see it in this chapter, so don't worry about it on the test. But the derivative of natural log of x is 1 over x, which is kind of crazy. So x times derivative that. Now, the outer rule is the power rule, and then you multiply by the derivative of what's inside, which what I just told you is 1 over x, plus natural log of x squared times derivative of x is 1. So then we're going to try and clean it up. And here the x's cancel, so we get 2 natural log of x plus natural log of x squared. Now we can't move this 2 out in front like you might be thinking of that power rule for logs. It's got to be on the inside to move it out front. But look at these answers. Most of them have like a natural log of x factored out of them, so let's try that. Do you see that answer? So, I mean, this answer was fine for response, but we're at the mercy of multiple choice answers, so we got to sometimes do extra work to make them look like the right answer. Okay, number 5, we're looking for the fourth derivative. Now look at these answers. There are these exclamation marks. 4 factorial is 4 times 3 times 2 times 1. You should have seen that in previous math classes, factorials. I don't think we brought them up in this class yet. So fourth derivative. So the first derivative is, now we might find a pattern here, or we might just go ahead and keep finding it. It's 4, 2 plus 3x to the third power. The second derivative is, now look at all these answers that have 4 factorial in front. So we're probably going to get a 4 times 3 times 2 times 1. So in the next step, when I get 4 times 3, and where I would usually go ahead and make that a 12, I'm not going to. I'm going to keep it like that, because I'm looking for 4 times 3 times 2 times 1. The next one, get another 2. Again, I would usually make that 24, but because I've looked at the answers ahead of time, I know what I'm trying to do. So this is going to be 4 times 3 times 2 times 1 times 2 plus, oh, you know what? I was making a mistake on all these. Shoot. Look at all these have 3's to a power. I should be concerned I'm not getting that. So the first derivative, I forgot to do the chain rule. So you get an extra 3, which I'm going to go ahead and keep back here. And then you get another 3 in the next one. And so we have 2 3's. And the next one, we get another 3. And the next one, it's 2 plus 3x to the 0th power, but times derivative what's inside is 3. And you have these other 3's already here, 3 of them. Now that's just going to be 1, so the answer is going to be 4 factorial, 3 to the 4th. Now usually I would probably multiply all those numbers out and get these big old numbers, but based off my choices, I wasn't doing that. Okay, so all right, so look at the answers. Even when you start, it gives you some good ideas of how to try and organize your work to fit those answers instead of trying to recuperate at the end and do a bunch of extra work to undo the work you've done. Look at these answers. 4x to squareds, 2x to fifths. I bet it's one of these. I mean, it'd be weird if it was just one answer that was totally different than the rest. Usually the right answer has a bunch of other answers that look really close to it. So to derive this would be product rule. So it would be 3 times 4x squared times derivative of what's inside. I mean, we could have changed this to like 64x cubed, but that doesn't really look like the answers here. Now, this is going to be product rule, so you know what? Let me start over. Product rule, I'm going to usually leave the first one the way it is, and then derivative of the next one. And then chain rule right there. And then plus the second one times derivative of the first one, which is going to be 3 4x squared, but then chain rule, don't forget that 4. I bet there's an answer here that for the people who ignore the chain rule now. This is 12, 4x to the third, 2x to the fifth, plus 12, 4x squared, 2x to the sixth. Now I'm leaving like that because I see all these answers with 4x to powers and 2x to powers. Now, here's something interesting. Could we make both of these have a 4x squared and a 2x to the fifth? Like this one, we could take one of the 4x's out of this, and then that would be 48x. And then there would be a 4x to the second, 2x to the fifth, right? And then this one has a 4x squared already, so that's good. But it has an extra 2x, so I bring that out, and that'd be a 24x, 4x squared, 2x to the fifth. And now they're like terms, so we can combine them together, and we get 72x, 4x squared, 2x to the fifth, which I believe is on there. Dang, that was tricky. It's tricky just to get the answer to match their answers. Calculus wasn't that bad. I mean, if I were to do this by calculus, I probably would have changed this to 64x cubed plus what's 2 to the 6th? Third is 8, fourth is 16, third 2, 64 x to the 6th. And then I would have just taken the derivative of that. It would have been super easy. But wouldn't have given me one of these answers. Okay, number 7, 50th derivative. So we've been doing these. So the 0th derivative is cosine x. First derivative, negative sine x. Second derivative is negative cosine x. Third derivative is positive sine x. Fourth derivative is cosine x. And now we're back to the beginning. So this is groups of 4. So we can do long division, take out all the groups of 4. And look at the remainder. So that means that the 50th derivative should equal the second derivative, which is negative cosine x. You guys should be getting good at that little kind of trick. Okay. So next one, 20th derivative. Now be careful, don't assume like this has an extra 2 in front. Look at all these 2's to the power. So I'm going to go ahead and try and figure out a pattern here. There might be a couple patterns. So the 0th derivative was sine 2x, right? The first derivative is going to be cosine 2x times 2, right? The second derivative is going to be negative sine 2x. There's already a 2. There's going to be another 2, right? And we can start putting this front. The third derivative is going to be negative 2 to the second power. I'm going to do 2 powers because I'm looking at these answers. The derivative of sine is cosine, and then you got a chain rule. So you get another 2. So the fourth derivative is going to be negative 2. We already have, it's going to be negative 2 to the third, which is over there, and then a negative sign, and then a chain rule, and you get another 2. Now, if we simplify these as we're going, you'll notice that we have 2 to the 0 sine 2x, 2 to the first cosine 2x, negative 2 squared sine 2x, negative 2 cubed cosine 2x, and this one's going to be positive 2 to the fourth sine 2x. And one thing is we're back up here to the top as far as the sign goes. So there's that pattern, but then it seems like whatever derivative you're on, you're going to have a 2 to the nth power there. So the 20th derivative, we're going to do a little long division real quick. 20 divided by 4 is 5. Remainder is 0. So that means we're going with the sine x, but there should be a 2 to the 20th power in front, sine of 2x. So I think this is the answer. There you go. So 2 patterns, also at the mercy of the answers, which was actually kind of nice, having the 2 to the power so we didn't have to get some huge stinking number. Figure out 2 to the 20th ourselves. So here's, these next problems, these are the ones where just it walks like duck, talks like duck, sounds like duck, walks like duck, looks like a derivative, feels like a derivative. These are this you should be like, oh, this is a derivative, right? Of what function? X cubed. What's the derivative using the memorized rules? 3x squared. At x equals 2, or we're going to plug a 2 in afterwards. 12. That's the easiest way to do that problem. You actually don't do any of the limits of it. You can do a L'Hopital's rule. You can factor out the whole. I mean, you can do it. It's going to be 0 over 0 in determinate form. You can do it. But this is a lot quicker. Same thing here. You should start to, x plus h, x plus h. Whenever you see h's, you should probably be suspicious. So what's the function? It's here twice. Now, here it's usually a little more obvious because it just has x's in it. The mistake people are going to make is they're going to think it's 2x to the 5th plus 5x to the fifth. But remember, we subtract f of x. So that would be 2x to the fifth minus 5x cubed. And then when you distribute it, you get that plus. So this should be a minus. And there's an answer on there for the people who probably did the plus. So the derivative is going to be 10x to the fourth minus 15x squared. 10x fourth minus 15x squared. And here's the one for the people who missed that little negative issue. And unfortunately, you get 0 credit. So next one, that's a derivative. What's the function? Looks like tangent of 2x. Okay, well, what's the derivative of that? Well, derivative tangent is secant squared. But you got a chain rule. Don't forget the chain rule. Get an extra 2. So it should be 2 secant squared 2x. Here's the people who forgot the chain rule, which is a super easy mistake to do. 12. We've done this. The function is absolute value. So what's the derivative of it? And then what's the derivative at 3? Well, I think the easiest way is to just sketch a graph. This is an absolute value graph right here, right? And 1, 2, 3. What's the slope right here? Slope is 1. Done. You can do that a little more technical with piecewise graphs and all that stuff, but it's going to take longer and it's a lot harder. So sometimes just draw a picture. Okay, a little implicit differentiation, which we've been doing a lot of lately, so that should be fresh in your head. So derivative of x is 1 plus dy dx equals, you got a product rule there, x times derivative of y is dy dx plus y times derivative of x is 1. So don't forget the product rule. This is what we want. We got to get it by itself. So we get the dy dx's on the same side. Dy dx minus x dy dx equals y minus 1. Factor out the dy dx. So you can group them together. Divide both sides by 1 over x. So do you see that answer? Ooh, no, the bottom is messed up. Ooh, I don't see it. Now consider that maybe if you factor negative out of everything on the top and bottom, or multiply the top and bottom by negative 1, that would give you 1 minus y over x minus 1. Do you see that answer? Ah, there it is. Sometimes you gotta manipulate your answer. Okay, 14. Implicit 2y dy dx minus, now be careful, 2x dy dx plus y times derivative of 2x is 2 equals 0. Now you got to make sure you distribute this negative. So a lot of times I put parentheses around my product rules just to kind of see them, make sure I don't forget to finish them, but also to distribute stuff that need to be. So that's going to be 2y dy dx minus 2x dy dx minus 2y equals 0. So we're going to factor out the dy dx out of those two terms, 2y minus 2x. We're going to add the 2y to the other side. We're going to divide both sides by 2y minus 2x. I would probably usually instinctively factor 2 out of everything on the top and bottom. Oh, and then we're supposed to plug this xy in. So I actually should have done that like here early. Gosh, kind of frustrated. I did all that extra work. I didn't read the problem. Now I could do it here. That's fine. Negative 3 over negative 3 minus 2 is going to be negative 3 over negative 5 should be positive 3/5. But, I mean, it might have been a little quicker if I just plugged in the x and y pairs. I don't know if you guys remember that idea. So now I'm going to be keeping my eye open for that. Also, looking at the answers would have maybe made me think about that too, and I just was going too fast. Cosine xy times derivative of what's inside. Now you have to put parentheses around this. This is a product rule. X times derivative of y is dy dx plus y times derivative of x is 1 equals 2x. So here's your dy dx. We could distribute this. And then subtract this to the other side. And then divide both sides by that. Okay, now that would be a perfectly good answer, but look at all the answers. They all have secants. What is secant? Secant is 1 over cosine. So we got to somehow get some 1 over cosines. Maybe if we distributed this, it'd be 2 over cosine xy. The x's would cancel, minus y over x. I mean, I don't know if that's going to be better. I mean, this would be 2 secant xy minus y over x. I don't really see that. Maybe we need to combine it back to a single fraction. That'd be 2x secant xy minus y all over x. I mean, I had an answer right here. And I changed it, and then I changed it again, and then I changed it again, and I think I finally see it. E. Now see, multiple choice is not your friend. Okay, now this time I'm going to be smart. I know I'm going to get a numerical answer, so I'm going to try to save myself a little bit of hassle. And I got to take a derivative, x squared times dy dx plus y times 2x. It's the first product rule, and then there's another product rule. Y times derivative of x squared is 2x plus x squared times dy dx equals 0. Now, this is what I want, but I'm not going to try and get a beautiful dy dx equation with x's and y's in it because I know I'm going to plug numbers in eventually. So let's just do it now. So 1 squared dy dx plus 3 times 2 times 1 plus 3 times 2 times 1 plus 1 squared dy dx equals 0. So we have 1 and 1, so we have 2 dy dx, right? We get 6 and 6, so that's 12. So we're going to subtract 12 and divide both sides by 2. And we get negative 6. A little quicker, I think, than if we try to get this beautiful equation. Now I have a different answer than what I wrote here, so let me double check it. Did I make a mistake anywhere? I was going pretty fast. Second derivative. Shoot. Now the work I did isn't for nothing. But I think we actually do want to get dy dx by itself. Oh my gosh! So I got so eager to take a shortcut that I did it at the wrong time, and the answer I got was on there. See, that's how tricky they are. So we got to do the second derivative. Now I think you want to get dy dx by itself in terms of x and y to do that. So we have dy dx, and then we have 2x squared, and then on the other side we have negative 4xy. And so that's going to be negative 2y over x is your dy dx. I'm going to use that answer. I mean, I don't know if it really helps me much. So now I'm going to do second derivative. I'm going to do quotient low d high minus high d low all over low squared. Now at this point, I'm going to start plugging x's and y's. So I have x value of 1, and I have a negative 2, and then dy dx, let's plug in negative 6. So I'm going to use that work. Now, if we hadn't figured that out yet, I would have then figured it out here, which would have been pretty easy, right? And then plug that into there. Or you could plug this. I mean, that's the quicker way to do it. Plus 2 times y is 3 all over 1 squared. So this is going to be positive 12 plus 6 is 18 over 1 is 18. Ugh. So I just illustrated how dangerous multiple choice problems can be. last page. Finally, it says the equation of tangent line is which one? Well, you got a point, so that helps. You need the derivative. So I guess we should do y prime equals low d high minus high d low all over low squared. Now, since we're going to plug number in, let's just start plugging number in now. So we plug 1 in here. That's going to be 1 times 3 is 3. If we plug 1 in here, that's going to be 7 times 4 is 28. Plug 1 in here, it's going to be 1 squared is 1. So it's going to be negative 25 for the slope. So I would do y minus 7 equals negative 25 x minus 1. Now, usually that's a perfectly good answer, but now I got to look at these answers and be like, well, they all kind of look like standard form. Like we want to get the y and the x on the same side. So let's get rid of the parentheses, distribute. Let's move the x's over to the left, add the 7 to the right. There we go. I mean, I had a perfectly good answer any other time, but multiple choice. Had to do extra. Okay, 18, another equation of tangent line. You have the xy pair. I would probably just do implicit on this one. I feel like that's going to be the quickest. It's a circle, but 2x plus 2y dy dx equals 0. This is what I want, but let's just plug numbers in now. 5 for x, negative 12 for y. And so it's going to be negative 24 dy dx equals negative 10 divided by negative 24. So dy dx equals 5/12. Okay, so we're going to do y minus y1, which is negative 12, so it's plus 12 equals 5/12 times x minus 5. Perfectly good on any of the problem, but multiple choice kind of look like standard form. So we could, distribute. And then clearly we need to get rid of fractions at some point. So I think it's better to do sooner than later. So you get 12y plus 144 equals 5x minus 25. And so, I mean, it looks like in all these answers, the x's are positive except for that one. But so I think we're going to do 5x minus 12y over here. And then add 25 over here would be 169. That's standard form. And that was kind of annoying. Extra work. Okay, we're looking for the derivative of this absolute value function. So what we've done just recently, is just draw a picture of it. What is this? This would be a V graph like this, right? But it's been moved to the right 2 and up 3. So now it's something like this, right? What's the slope at 2? Right here, what's the slope at a corner? Doesn't exist. Ooh, tricky, right? Okay, but just graphing it, I think made that pretty obvious. Here we want the derivative 0, so I think we're going to do, let's find f prime of x first. So I see a little product rule. Derivative sine is negative sine, derivative cosine is negative sine, plus cosine x times derivative of that's going to be 2x minus 1 to the first power. Derivative what's inside is a 1. So then we're going to plug 0 in, and so that's going to be positive 1 times sine of 0 is 0, plus cosine of 0 is 1. If I plug 0 in here, that's going to be negative 2, so it's going to be negative 2. Yeah? Okay. All right. Last few. 21, f and g are different functions. So we had something like this on the homework. So we're going to do h prime first. Is a chain rule. Derivative the outer function first, leave the inside the same. Chain rule says take derivative of what's inside. So then we're going to plug 1 into all of this. I think it's just better to take your time on these, show your work. G of 1 is 3, right? Or from the inside out, order of operations. F prime of 3 is -5. G prime of 1 is -3. Final answer is +15. So we've done a lot of those. It's kind of like the function tables, but equation of the normal line. Okay, at x equals 3. So first thing I'm going to do is find the y value because they didn't give it to me. So that's going to be the cube root of 8, which is 2. So the point is at 3 comma 2. So now we need the slope, y prime. So I'm going to think of this as a 1/3 power. So it's going to be 1/3 x squared minus 1 to the -2/3 times, don't forget the chain rule. I bet there's an answer on here if people forgot the chain rule. So then we're going to plug 3 into this. So that's going to be 2 times 3 over 3 squared minus 1 to the 2/3. So it's going to be 6 over 3 times 8 to the 2/3. Now, whenever I do rational exponents, I do the bottom first. So that's 8 to the 1/3 and then square it afterwards. So you do the cube root, makes the number smaller. So that's going to be 2, and then squared is going to be 4, and then there's a 3 there. So it's going to be 6 over 12, which is 1/2. That's your slope. So then I do y minus 2. Now that's the slope of the tangent line. The slope of the normal line is perpendicular, so it's -2. I bet they have an answer here for people who use the tangent line. So -2, x minus 3. So this would be perfect for any other problem, but look at these answers. So we got to manipulate this. Maybe add the 2x to the left, add the 2 to the right. Do you guys see that answer on there? Kind of like a standard form. Okay. Let's see. Do they have the answer for the people who did the tangent line? Let's check it out. I bet they do. I don't think you see it. So I guess he got lucky. Unless I did something wrong. I guess they didn't have it. Surprising. Okay. All right, last one. At the point of intersection of these two graphs, the tangent lines are, and you're allowed to use a graphing calculator, so why not? Let's graph them. Your calculators can find intersections, right? So cosine x, make sure you're in radian mode. And then 1 minus x squared. And I don't know about the window. We could do -10 to 10, -10 to 10 first, just to see what happens. Graph it. So there's the cosine curve, no surprises. There's the upside down parabola, so it makes sense, right? And it's upside down parabola shifted up 1, so it hits right up there at the top. So if we wanted, we could make the window a little better. If you, I don't know, -5 to 5. -5 to say 2, get a little closer view of it if you want. Do you think the parabola is going to cross that cosine curve any other time? Nope. So right there, I'm going to draw a picture. I mean, usually if you're using your calculator, I kind of want you to sketch a picture what you're doing. So looks like the intersection's at 0, 1. And it says, what were they asking us for? They were saying at the point of intersection, the tangent lines of each of them, I would say, are both 1, right? The parallel lines are the same line is the best answer. I mean, they are parallel technically, but I would say they're the same line. Now, yeah, I mean, that seems like the quickest way to do that problem. So there you go.